You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
Datastrato provides a unified data and AI catalog that simplifies metadata management across complex data platforms. Powered by Apache Gravitino, a top-level open-source project and high-performance federated metadata lake, it unifies governance across diverse data sources, engines, formats, and clouds.
Hello and welcome everyone to the New Stack Makers. I'm your host, Heather Joslin of the New Stack, and today we're going to take a deep dive into an open-source project called Gravitino. This is a high-performance, geo-distributed, federated metadata lake. This past June, it graduated as an Apache top-level project. In December, it delivered its first major stable release, version 1.1. And at the beginning of this year, 2026, it joined the brand new Agentic AI Foundation. What is Gravitino? What are the problems it solves? And where does it fit into this rapidly expanding AI infrastructure landscape? Our guide for this conversation today is JP Du, founder and CEO of Datastrato. Hi, JP.
Hello, Heather, and welcome, everyone.
Thank you for joining us. JP, can you tell us a little bit about Datastrato and what your company does?
Of course. So I'm Junping, and most people call me JP. I'm founder and CEO of Datastrato. We are, the project Apache Gravitino, the company behind this project. In 2023, we actually start the Datastrato. So we are a data and AI infrastructure company that focuses on building AI native metadata and governance control plan for the modern data platforms. As I just mentioned, we are the original creator of Apache Gravitino, an open source catalog of catalogs designed to unify the metadata, access control, and the governance across the structured, unstructured, and AI data in multi-engine and multi-cloud environments. So actually, just like I mentioned, Gravitino is metadata unified metadata center. It's a control plan in the multi-modality of data, for short.
Excellent, and thank you for that, JP. And let's just get started digging into Gravitino. What problem was it intended to solve originally?
Yeah, so just I mentioned, we are a catalog of catalogs because we will try to solving the problem of running the data and AI data platforms to more safely and consistently. We're providing a single engine neutral control plan for metadata and governance, especially for the current age of AI agents. Before Gravitino, there definitely there's already some data catalogs, right, such as Pattern, Alation, and on some of the open source as well. But this is previously for BI use case for governance only. But now we need a more engine friendly or AI agent friendly metadata and try to unify everything together and providing we call it the technical metadata to the engine support as a first class citizen support.
How does it can you walk us through a little bit how it works specifically? How does it sort of under the hood?
Yeah, so it's actually it's actually comparing with the previous business catalog. Usually what we do is try to collecting, no matter it's actively or reactively collecting some of the metadata schema information, right, into another data platform, right, and do some consumption of the metadata and building some information on top of that. So this is the previous way to building that. So we are building a different way is we are hooking, we're building the whole platform into different data systems. We try to embrace all this, sub catalog of this data platform. So that's why we call the catalog of catalogs. In this way, we try to building a unified data catalog, no matter it's traditional structured data or like tables, like a database or data warehouse, or even a lakehouse, or it's something new like file system, like multi-modality data formats like a lens. We all take this kind of data formats, and we allow the multiple engines can access this kind of data. So that's no data silo anymore, and also it can be easy to consume by AI agents instead of previously we have to be building everything to be a data warehouse and consume from there.
It's always interesting to me, like the sort of the origin story, if you will, of an open source project. Was there a moment when you were just sort of eureka? We need to build this thing.
Of course.
Yeah. Can you describe that?
Yeah. So basically, I would say Gravitino is not from an abstract product idea, right? It's actually started from a practical and recurring problems, right? So the founder of Gravitino is my colleague Jerry and I. So our background, for my background, is about 15 years in building data infrastructure from the first generation of Hadoop infrastructure, and my colleague is building Spark, right? And now together we're building like cloud data warehouse and lake houses. So from these years of careers, we found some problems actually are more and more critical, right? Especially when data and AI system is growing more complexity. So all the teams have to consistently run into some issues. Like the first one is actually data is spread across multiple engines like Spark, Trino, or even some AI runtimes like Ray, PyTorch, right? And another problem is the metadata, or sometimes we call it a catalog, right? It's lived in it's a siloed catalog instead of a unified catalog to know everything, right? So in that means the governance, access controls, and even the semantics are hard to build in an efficient way. Sometimes it's duplicated, inconsistent, or even missing piece. Based on that, some new AI workloads, it's hard. They will make this thing problem even worse. Especially for unstructured data, because it's hard to manage, right, in a typical way. So in the real production environment, especially for the large data intensive companies, they actually know a single and authoritative place to define what data exists and how who can access it and how it should be governed. So we see the problem, we try to jump in and help them solve these problems.
And when it was built with Java, correct?
Yeah.
Why that choice instead of, say, Python? Or
so actually, we actually support the Python clients, but yes, it's mainly built with Java. In the beginning, for data ecosystem friendly, most data technology like Spark, like Flink, like or even Iceberg, right? It's building with Java ecosystem, Java and Scala, right? So this is one of the reasons. Another reason is we actually is building the a core control plan, right, server, which is we have tons of experience in building and operate for many years for high concurrent, right, and a stable and enterprise ready, multi-tenant load. So one short, we are not just building for AI developer, right, but also we are building the Gravitino for the operator, the DevOps, who maybe have some tons of experience to maintain the Java framework, but also for AI developers, we also providing the Python clients. So it also can be easy to consume by like PyTorch, by Ray, by Daft, or some new compute engine framework to consume. So that is a trade-off we do.
What is it? Let's talk a little bit about what does it mean for metadata to become the control plane for agentic AI native infrastructure?
Yeah, the thing is, so let us think what is the metadata means. So metadata actually means the data about data, right? So that means the data is not for only for AI, but actually can be a better one that can be powered by AI, right? This is the first to me. The second things, if we want to AI to understand the data in a better way, we have to building something like we call it a semantic layer, right? And which need a more metadata to understanding how the underlayer data can be used, can be processed, and also the control plan. The control plan means we have to control these of who can access the data and who can and how to access the data in some proper way. So what is a natural component or natural place to put that? I would say it's definitely a metadata system. But unfortunately, currently the metadata system is it's for many cases it's a building component within one engine, right? Like Databricks or Snowflake or some other data platform, right? But actually, what enterprise or company need is a unified and open solution, right? To cataloging all this data into a unified metadata lake, so that we can building a control plan. We can figure out, when to use what engine to access what piece of data. So that is very important and essential.
What do you see as some of the best use cases for Gravitino? Especially, maybe a lot of our listeners work for enterprises, especially for maybe larger organizations that,
of course,
are getting deeply into AI.
Of course. So, I mean, the couple of the best use cases. The first case is maybe the multi-cloud data consolidation, right? So we have a very big customer, one of the largest internet technology companies in the US, right? They have a tons of data. Many of them are unstructured data. So the data is distributed into on-prem and to public clouds. So their compute resources, especially GPU resource, right, are distributed over several clouds and regions. So they need they want the same data, right? It's available for all these kind of clouds and regions, so then they can trigger the training jobs or inference jobs or their applications in anywhere, right? This is very, very important and critical to them. So a unified data catalog is very critical, right? In this case, to make sure all this data is secure and consistent, right, across all the locations. Without a control plan, without a unified metadata center, they cannot do this, right? Another case is try to building a lakehouse as a service, right? We know Iceberg it's very popular. It's almost we can see the de facto standard as the lakehouse table format. Yeah. However, unfortunately, Iceberg itself it's only a library, right? It's not a service. It's providing the table metadata layout, like manifest, the snapshots, right, schema, revolutions, and also providing APIs for building and writing the tables and guarantee like ACID, time travel, and maybe snapshot isolation. This kind of rich features, right? But what it doesn't provide, it's actually a long-running server or control plan, right? And for centralized access control, multi-tenant isolation and support, and operational lifecycle management, this kind of work, it doesn't include in the Apache Iceberg. So and also some table maintenance efforts is needed. It's a big problem if the table scale coming up. So definitely Gravitino REST catalog, Iceberg REST catalog, happy fitting all these problems. Beyond that, I mean, a new scenario is becoming more important recently, which is building multi-modality lakehouse. So basically, in a real multi-modality lakehouse, you typically have maybe some structured data, right, such as iceberg or hoodie tables, or you can have unstructured and vector data, something like vector database or PG vector, or you have some lens tables, and also you have to manage in different multiple engines like Spark, Ray, right, and some new engine like Daft, right, and also your consumers of data is not only data analysis, right, but also the rec pipelines, the EA agents, right, the multiple new data consumers, and the environment is complicated, right. There's a dev environment, there's a production environment, also some staging environment, even cross the multi-cloud on-prem, right. Without a control plan, right, this is kind of a system. It's managing their metadata differently, security roles, duplicated, inconsistent. It definitely, the vector database is becoming a governance blind spot. This definitely need make the Gravitino. It's a very strong requirement in these scenarios. That means, those Gravitino is very essential in all three cases, major cases.
With the and one question that's always interesting to me is as new projects, new products enter the ecosystem with players like Databricks, Snowflake, and other large platforms offering metadata features. Where does Gravitino fit into that landscape? What gap does it fill?
Yeah, so actually, I would say it's kind of a platform native data catalog, right? So first it's more like a platform centric. It's building into Snowflake ecosystem or Databricks ecosystem, right? It's not an open, vendor neutral or engine neutral standpoint, right? And also for we need a kind of runtime enforcement, right, for different engine to apply the same security restraint or this kind of governance, right? But the platform native catalog can apply its own catalog only, platform only, but it have a very weak control on the open systems, right, support. And third things is just like I mentioned, the multimodality data should be treated as a first class citizen, right? But this is the platform native. It's more like focus on the previous one, which is table or structured data. Maybe the treating them as the most important, and the multimodality and the new data formats is is support lately as a secondary priority citizen things. And there are also some other different like multi-engine strategy, like open ecosystem protocols support. So that's define the Datastrato and the Gravitino to be unique comparing with Snowflake, Polaris, or Unique Catalog from Databricks.
And also the open source metadata projects landscape is got a lot of other Data Hub, Atkinson, Open Metadata. What differentiates Gravitino from those projects?
Yeah, it's just like I mentioned. This is more like human centric. Like then its catalog is for human, right? It's not for machine. So the Spark engine, Trino engine, they cannot consume the metadata directly as a single source of truth, right? But Gravitino is a technical metadata center, which is this means that no inconsistent with metadata, so that it can be engine friendly or engine centric, right? This is the key difference. And another difference could be the Gravitino is including not the logical metadata like schemas about the table or something. It also can have some physical metadata, which means how to do the index, right? How to caching policies, and also some table maintenance services also can be included in the Gravitino. So that means Gravitino can potentially, with AI powered, right, can make the data platform more efficient instead of a independent system outside of existing data system, right? So this is the second one, and third one is for multimodality, right? I have to highlight that because a lot of our 10 years or decades or more than decades, is most of the data efforts actually spent in structured data, right? These kind of tables. But now it's a timing to treat the unstructured data as a first-class citizen. So we're designing to support vectors and files or even other table formats in the same level as table, right? So these are all differences.
In December, Gravitino released its first stable version, version 1.1.0 was released. What's new in this version?
Yeah, so every 1 or 2 months we actually release a major release for Gravitino. It's the whole community is running very fast, right? So actually, the 1.1 release is a very important one. The first thing is we continuously to improve the AI and the multi-modal data readiness, right? We're providing the native lens REST catalog support, and we also prove that the new DAFT engine is also support with 1.1, and also we have a broader lakehouse support. So we call it a generic lakehouse catalog, which means the Gravitino can be more extensible for the new table formats or other new engines comes out. And we also enhance the enterprise security as long as some legacy platform and migration friendly, like new high versions, easily to transition from the old one to the new version of data platform, and also there's some operation and scale optimization there to support multiple cluster, no matter it's deployed in on-prem cluster or multi-cloud cluster. So that's our enhancement for 1.1 release.
And what's on the roadmap for the project and for Datastrato in 2026?
Yeah, of course. So basically, there's some roadmap for Strato as long as Apache Gravitino, right? So so basically for Apache Gravitino, I think we're along the way. The first thing is more the multimodality lakehouse support, right? As a control plan, we will support both multimodality data as long as the traditional lakehouse. And also the second things is we are more agentic AI friendly. That is, we make the agent can be consume the data more easily, right? So we know that the agent consumption data is quite different with currently what a BI application is built, right? The BI application build is we try to find the human find the data and try to building the data warehouse and data mart, right, and serving for the BI. But agent is more proactively to try to discover the data, right? So a lot of the effort should be spent in discover the data. So at the centralized metadata center, so we definitely provide a more value or convenient way for the agent to discover or describe the data is consumed. So this is AI native or agent native metadata direction is we are strengthening. Yeah, there are also other part of the support in our roadmap, like more engines, right? So far, if you look at Gravitino, it's more support like open source engines, right?
Mhm.
In 2026, we'll support more, more engines for open, no matter it's from open source or even not open source, but it's mainstream, right? That we all support.
Mhm. And one final question: what made you decide to bring the project to the Agentic AI Foundation?
Yeah. So there's a new AI foundation. It's called Agentic AI Foundation, right? So definitely, we believe the project we now it's building for Apache, as long as some components maybe building for the new foundations is for agentic AI, right? A
Mhm.
lot of comments today is talking about we're actually it's not agentic AI year, right? It's agentic AI decades. So as an infrastructure, as a data infrastructure, so now we are facing the serious problem. Does agentic AI really need a data infra? So my answer is yes, but it need to change. So what kind of change? Just like I mentioned, the most different is it's change. It's permanently changed how we consume the data. Right. Previously, it's human prepare the data and then ingestion into something like data warehouse or data lakes, and then
Mhm.
consumed by the BI applications, right? This is the previous way, but now it's different. I mean, machine generate the data, and AI consumption data is very natural. So the only thing we're focused on is try to making the metadata layer it's more intelligent and more
Mhm.
cataloging. It's more easy cataloging all this metadata into the same place to which is easy to governance the data consumption, right? And
Yeah.
also agent it should be there should be more agile way for agent to figure out about the data permissions, this kind of problem, instead of previously it's the scientist, data scientist, or a data analyzer is try to asking for permission in some complicated workflow, right? So now definitely it didn't work for agent. So we need some centralized policies and governance ahead of that. So data governance is something must thing. It's not optional anymore. So that
Yeah.
is totally different.
Yeah. And being under the umbrella of a foundation
Of course. So
would help with that a lot.
we cannot solving the problem alone, right? We have to work with other agent AI builders and
Mhm.
also like MCP server builders. This is not a data platform itself problem, right? It have to
Yeah.
work with all these these parties to figure out
Mhm.
open standard or open solutions for make all these things happen.
Okay, and that seems like a good place to wrap up. Thank you very much, Junping JP Du for of Datastrato for joining us. Thank you, JP.
Yeah, thank you, Heather.
And I want to thank all of you for joining our conversation. This has been Heather Joslin for the New Stack. We'll see you next time.
See you.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.